In this video, I'm going to talk about the absolute value family, and we have 3 learning targets. We're going to graph absolute value functions and talk about their domain and range. We're going to talk about dilations, which is, in the warm-up, will be sought as the vertical stretch, vertical shrink, horizontal stretch, horizontal shrink. Those are called, the fancy word for it is dilations. Then I have learning target number 3, which is I'm going to write equations of transferred functions. So we talked about reflections, we talked about translations, we talked about now vertical stretch, horizontal stretch. We're going to include all of those things in one equation now. Okay, first I'm starting with talking about absolute value functions. So to do that, I'm going to just talk about the parent. Well, the parent function is the most basic of the type. It's just the absolute value of x. Y equals the absolute value of x is my parent function for an absolute value function. I'm going to draw this again. I know I already drew it like 5 times, but I'm going to draw it again. What I notice about it is that its lowest point is its vertex, which is at 0, 0. I know that to the right, the slope is 1. So as I go to the right one, I go up 1, right 1, up 1, right 1, up 1. And then this is the right-hand side of my absolute value graph for the parent. And then if I go, I know that there is an axis of symmetry, just like there was for a parabola. Both sides are going to be the same. One's going to be reflected over the other, over the axis of symmetry. Okay. If I do -1, I'm going to have +1. If I plug in -2, I'm going to have +2. And if I plug in -3, I'm going to have +3. And so these points are just reflected over the axis of symmetry that I have. And that's my parent. I just want to also write down, and you should write down, that the slope on the right-hand side is 1/1 on the right. Okay. The domain is always going to be the same for every absolute value function. It is, what? No, it's not. It's -infinity to +infinity. It goes on and on forever in both directions. The range is going to be the lowest y value, which is 0, to the highest one, which is infinity. 0 is going to have a bracket because it's included, and infinity cannot be contained, so I put a parentheses on it. The next learning target that I'm going to talk about is dilations. So dilations is just a fancy word of explaining what the vertical stretch, vertical shrink things are. So a dilation, it's just expanding or compressing a graph vertically or horizontally. And I'm going to write the format. It's a template that we're going to use to talk about this. So I have y equals, and then some coefficient a, times f of x, except it's going to be f of bx, in case there's a coefficient in front of the x inside of the function. So I'm going to use this template to help me talk about dilations. So if I have a in front of the function, it's going to tell me if I have a vertical stretch or if I have a vertical shrink. If I have a vertical stretch, that means the absolute value of a is greater than 1. If I have a vertical shrink, that means the absolute value of a is less than 1, or a fraction. Okay, a whole number coefficient, then it's a vertical stretch. Fraction coefficient, it's a vertical shrink. Then I have b. Oops. So b is the coefficient inside of the function. That tells me if I have a horizontal shrink or a horizontal stretch. If I have a horizontal shrink, that is when the absolute value of b is greater than 1. Horizontal shrink is the same thing as a vertical stretch in that it makes the graph steeper than the original function, than the parent function. If I have a horizontal stretch, it is the same thing as a vertical shrink in that it makes the graph less steep. And that happens when I have the absolute value of b is less than 1, or a fraction. So the only difference between a and b, a is on the outside of the function, so I explain what's happening vertically. B is inside the function, so just to keep it consistent with everything else we talked about, we're going to talk about what's happening horizontally. Vertical stretch is the opposite of, is the same thing, vertical stretch is the same thing as a horizontal shrink. Vertical shrink is the same thing as a horizontal stretch. And the last learning target, we're going to talk about the template that you can use to transform any function. So we're going to talk about transforming functions. And then the template that you can use to do all the transformations we talked about. And that is y equals plus or minus some coefficient a times f of x, except we have some stuff that could be inside. So f of, there might be a coefficient b, there might be a plus or minus coefficient b. And then I would multiply that b times x minus h. That's how I'm moving left or right. So this is all of the stuff that could be inside the function. You might not always have all of those things. And then on the outside of the function, the last thing that we can include is that plus k. So let's talk about what all of this means, or remind ourselves what all of this means. If I have plus or minus, I'm going to write this down here because I have enough, I need space. If a is negative, I don't care if it's positive, it's not going to change anything, but if I have a negative in the front, then I know that it's a reflection over the x-axis. We also talked about if b is negative, so that's the coefficient inside is negative, then I know I have a reflection over the y-axis. Then the next thing I want to talk about is a. So I know a is a vertical stretch or shrink is what that tells me. The next extra variable I have is b, and that tells me if I have a horizontal shrink or stretch. If it's a whole number, it's a shrink. It's a horizontal shrink. If it's a fraction, it's a horizontal stretch. Makes more sense vertically to describe it vertically. If it's a whole number, it's a vertical stretch. If it's a fraction, it's a vertical shrink. Then the h is going to tell me how am I moving left and right. And then the k tells me up and down. And that is transforming functions.